Okay, dear students, in the last class we have finished 3 questions. That means up to question number 3 in exercise 5.1. Okay, this belongs to continuity and differentiability. Let us proceed further. Total 34 questions are there. We will do up to question number 10 in this class. 4, 5, 6, 7, 8, 9, 10. Okay, we will try to solve up to question number 10. See question number 4, what they have given. Prove that the function f of x is equal to x power n is continuous at x is equal to n, where n is a positive integer. You see here, he is asking us to find the continuity of the function, but not in general form. In x to the power of n form, n is a positive integer. You cannot take any one number and see what we can say. Continuity, left hand limit, right hand limit, like all this. Okay, what we do, generalized form means generalized solution only we will see. We will substitute f of x and we will do limit also. Both we will show equal, then we will show that this is a continuous line. Okay, this question like that only we will do and finish. Okay, let us see what I am doing. You see, f of x is equal to x power n comma f of n is equal to, why? Because x is equal to n they have given. F of n is equal to n power n. Okay? Why? Because x is equal to n means in x place n you have to keep, in x place n you have to keep n power n as come. Okay. Now you see, limit also you find. Limit x tends to n. Why? Because x tends to n. F of x is equal to limit x tends to n. F of x means what you have tried? First you have tried x to the power of n, that is equal to, now you apply limit n power n. Okay. Now what you have to do, you have tried f of x is equal to limit x tends to n, that is why this is continuous line. You can write and close. Why? Because such type of problems you have to close simply. F of x is equal to n power n has come, limit x tends to n f of x. Okay, this also n power n has come. Therefore, this function is continuous at x is equal to n. Okay, see, normally this is very easiest method, but rather than left hand limit, right hand limit, or some steps, if you do like this, all problems, not I am talking about this problem, remaining problems are all problems. If you do in the simplest way, I don't think examiners are going to accept, are going to give full marks. Anyway, they have to give marks, but they may not give full marks. But in certain cases, they have to give. Why? Because in this question, we don't have any other option. This is only the option. Okay, let us close this question. We will go for fifth question. Okay. Okay, see the fifth question. This is a good question. Until now, all continuous functions we have seen. Now discontinuity will come in this question. Where it will come and all, you see, this is a good conceptual question. Okay, is the function f, this is the function defined by f of x is equal to x if x is less than or equal to 1, 5 if x is greater than 1. I already told you, if simple function comes means normally those are going to become continuous. If like these conditions are there, logical controls, these are called logical controls. Why? Because these are not directly equal, logical. If less than or equal to or greater than, see, this equal to will come for any one. You see, for one equal to or less than this one, if greater than, that means here again equal will not come. Once it has come equal to here means here equal to will not come, like that. X and 5. Okay, this is the function, and is asking to check the continuity at x is equal to 0, at x is equal to 1, and x is equal to 2. What we do, see, there is a possibility of discontinuity at 1 only, if it all discontinuous. Why? Because see, we have got some experience until now, several questions we have done continuity. Forget about this one, x is greater than 1. If this function is less than or equal to 1 means minus infinity to 1. X only. That means from minus infinity to plus, this is continuous up to 1. Okay, equal to 1 they have given, you see. Equal to 1. Minus infinity to, I am writing like this also, you see. First function, minus infinity to 1. Minus infinity, you have to keep this one. And over here, you can write like this. Why? Because equal to is there. From minus infinity to plus 1, first function. You see here, see, namesake one function, but here two functions are there. Like, why? Because f of x is equal to x, f of x is equal to 5. Both are there. Okay? F of x is equal to x up to from minus infinity to plus 1. Why? Because less than 1 means it may go up to minus infinity. Minus infinity, you have to keep open bracket. 1, you can close bracket. Why? Because equal to is there. Okay? Up to minus infinity to 1, this is continuous. Why? Because there is no other function. Okay? That is why 1, 0, if you see 0, 0 will be continuous only here. At x is equal to 0, continuous only. By seeing itself, we can say. Okay? That is why first we see x. Afterwards, you see here, down. Greater than x. Greater than 1. Okay, 1. That means there is no control. That means up to plus infinity. Plus infinity, you close this one. Here also, you see here equal to is not there. That means you have to keep open bracket. Because once you have closed, it means here you cannot close again for the same limits. Okay, if different are there, that means you can close here. Then equal to also will come. Equal to comes means you have to close. Equal to not come means you have to open bracket. This is closed bracket. Okay, open parenthesis, closed bracket. Okay. See, from 1 to infinity, this function is continuous. We know very well. Why? Because there is no other option. That means what I want to say, at x is equal to 2, this function is continuous. By seeing itself with our experience, we are telling. Okay? This also. But what about 1? You see, in one area only is equal to and these are changing. In one area, left hand limit, right hand limit, main limit, if you take 3 limits, one limit may come different. Okay? That is why there is a possibility of discontinuity at x is equal to 1 only. Why? Because see, we are going to do this question and we are going to find. But every time you don't find this much time. In objective type questions and all, for seeing discontinuity, what you have to do? You have to apply only one. In one area, if you apply automatically, discontinuity or continuity is going to know and you can put answer. To reach that, you have to get some experience. See here, 1 changing. The limit at 1 value is changing. That is why we have to see limit at only 1. Remaining all, you need not see 0 to are continuous. Like you can proceed further and you have to save the time. That's what I want to say. Okay? Let us proceed. First, what we do at x is equal to 0, we see. Afterwards, at x is equal to 2, we see. Both are continuous, like we will prove. And we go for x is equal to 1. There we will see whether continuity or discontinuity. Okay? Okay, see. At x is equal to 0. At x is equal to 0, comma, limit x tends to 0, f of x is equal to limit x tends to 0, f of x. You see, at x is equal to 0 means less than 1. Less than 1 is what? X. X means you cannot keep like that only. X tends to 0 means here 0 you have to keep. Apply limit, then 0. The value is 0. You understand now? Okay. Now you tell me, is it required to do left hand limit, right hand limit for 0? Why? Because until 1, you need not do. Continuity function is there. Okay? By see, how we reached this position now? Why? Because we have done several questions. That is why we reached this position. Now you can write left hand limit is equal to right hand limit is equal to limit extends to 0 is equal to 0. Like you can write now. Why? Because that much of experience we have got now. Okay? Okay. Let us write. Left hand limit is equal to right hand limit is equal to limit extends to 0 f of x. Therefore the function is continuous at x is equal to 0. That means first one is over. Continuous at x, yes. Continuous at x is equal to 0. Okay. Up to x is equal to 1, it is continuous. Minus infinity to plus 1. Okay. Same value is there. There is no change of value. Okay. Now you go for this one. At x is equal to 2. I am going for x is equal to 2, not going for 1. Why? Because 1 we will do clearly. 1 is going to change it may change. 2 at x is equal to 2. There also continuity will be there. At x is equal to 2. Write down. At x is equal to 2, comma, limit extends to 2, f of x is equal to limit extends to 2. Now, what is the function if it is at 2? 2 means greater than 1. If greater than 1, 5 you have to take directly. Now it has become a scalar function, limit of a scalar function. That means scalar. That's all. Okay. Now you tell me slightly less than 2, slightly greater than 1 also same 5 is coming. Why? Because see, greater than 1 means so always you have to take 5 means slightly less than 2 means 2 only. Slightly greater than 2 means 2 only. Then same 5 will come. That is why what you have to write? You have to write like this. Left hand limit is equal to right hand limit is equal to limit extends to 2 f of x. Okay. Left hand limit is equal to right hand limit is equal to limit extends to 2 f of x. Why? Because at x is equal to 2 we are doing. Now what you are going to write? You are going to write like this. The function is therefore the function is continuous at x is equal to 2. Okay. See, for 0 and 2, based on this logical controls, we have not done left hand limit, right hand limit, but directly we have written. But at 1 we should not write like that. Why? Because see, 1 equal to 0 and less than 1. Sorry, 1 equal to 1 and less than 1 function is continuous. But greater than 1 different function is there. There you have to see equal to left hand limit you need not see. Why? Because left hand limit is same only. Equal to 1 function we will see and greater than 1 function we will see. There if both are different then we can write discontinuous. Okay. First note down this. We will go for x is equal to 1. This one. Continuity at x is equal to 1. Okay. Okay. Now write down continuity at x is equal to 1. We are checking continuity. Continuity at x is equal to 1. Okay. Now you see we are checking continuity at x is equal to 1. What we are going to do? Apply limit at 1. Okay. First you apply limit at 1. 1 means equal to 1. This may be here or here, but you simply apply limit at 1. Limit x tends to 1 f of x, that is equal to limit x tends to 1 f of x means see, at 1 means equal to you have to take first. Left hand limit, right hand limit area, that is different, but limit x tends to 1 means first you have to take equal to area. 1 equal to where x is there, then you take x, that is equal to, apply limit means what? X is equal to 1, then 1. Okay. Now you stop and analyze. Left hand limit do you require to take? Why? Because left hand limit means less than 1. Less than 1 also same is there. Same 1 only will come. Okay. There is no use. Then you go for right hand limit. Greater than 1. 1 plus 5 is there. That means here 1 rather than 1, 5 will come. Then discontinuous, so you can write. Okay. Okay. Let us write. Right hand limit. I am writing, you see. Left hand limit I am not taking. Right hand limit, comma, limit x tends to 1 plus, right hand limit means 1 plus f of x, that is equal to, see 1 plus means greater than 1, slightly greater than 1 or greater than 1, 1 greater than 1 means 5 you have to take, 5. One more time you have to write now, that is equal to limit x tends to 1 plus 5, that is equal to 5. Now you tell me 1 is equal to 5. No. That means limit x tends to 1, x is, limit x tends to 1, f of x is equal to 1, limit x tends to 1 plus f of x is equal to 5 has come. That means both are different. That means the function is discontinuous at 1, x is equal to 1. Point of discontinuity, 1. Okay? Point of discontinuity is not this one, this one. Okay, input is the point of discontinuity. Here both are same, here both are same, but here both are not same, you see. Point of discontinuity is 1 means input. Okay, now can we accept that this is discontinuous? Why? Yes, because 1 and 5 both are different. Okay, write down. Limit x tends to 1 f of x is not equal to limit x tends to 1 plus f of x. You see, I'm telling gross root these. If you take, then concepts will be very clear. These are gross root level process, system, procedure. Okay, not equal. Therefore, the function is not continuous. Not continuous at x is equal to 1. Okay, not continuous at x is equal to 1. Logical, if you see, in one area only logical controls are changing. You see, equal to 1, greater than 1, changing x and 5. That is why possibility of discontinuity at 1 only. Okay, then you write point of discontinuity is x is equal to 1. Point of discontinuity is x is equal to 1. Okay, point of discontinuity x is equal to 1. This much you write and close this question. Okay, now see, this is first question, discontinuity has come. That is why we have taken much time. Then goes on, we reduce this much of time. Why? Because 34 questions are there. Let us go for 6th question. Okay, you see this question, first you understand the heading what they have given. Find all points of discontinuity of f where f is defined by, you see, even though they have written find the point of discontinuity, but there is no guarantee that every function is discontinuous. Why? Because some functions may be continuous. At the time what you have to write, this function is continuous, there is no point of discontinuity, like that. Okay, like that we have to write. Several functions they have given, one by one we will do, but the heading will be this one only. Okay, next question onwards I am going to remove this heading. We will write the function and we will see the discontinuity. Continuity you are seeing means you are finding discontinuity only, no? Both are same. Okay, see. Now you see, simply observe logically. Here, if at all discontinuity is there, where discontinuity will come? With our experience, you tell me. 2 only. Why? Because in 2 area, input domain, functions are changing. You see, 2x plus 3 to 2x minus 3 has come. When equal to 2 is there means 2x plus 3. Left hand limit also less than 2, 2x plus 3. Right hand limit greater than 2, automatically 2x minus 3 will come. That means if at all discontinuity is there, then it will be at x is equal to 2. X is equal to 2 means left hand limit, right hand limit, we have to see. That means from minus infinity to 2, equal to 2 is there, you see here like this. From minus infinity to 2, the function is continuous. Okay. Again, from 2 to plus infinity, but both are here open brackets, open intervals. Here one is open interval, infinity always open interval, you see. Okay. And 2 is closed interval. Why? Because equal to is there. This is continuous, this is continuous. That means if at all the discontinuity is there means at 2. At 2 only discontinuity may be there. Then we have to check discontinuity at 2 only. Like that you have to understand. Okay. Let us see. That means directly we will check the continuity at 2. That's what I wanted to say. Okay. Let me write down. You see, continuity at x is equal to 2. Continuity at x is equal to 2, comma, limit x tends to 2 f of x is equal to limit x tends to 2. See, first we are writing normal limit, not left hand limit, right hand limit. Normal limit means x is equal to 2 you have to take. X is equal to 2 means this one you have to take, not this one. Why? Because here equal to is there. Equal to 2. 2x plus 3. Right. 2x plus 3. Now you apply limit. 2 into 2 plus 3. That is equal to 7. Is it okay? But because in next place you are applying limit 2. 2 into 2, 4 plus 3, 7. Okay. Now limit extends to 2 f of x has come 7. You need not find left hand limit. Why? Because left hand limit also going to give same result. You have to find right hand limit. Okay. Let us find right hand limit. Right hand limit. Comma, limit x tends to 2 plus, right hand limit means 2 plus f of x. That is equal to limit x tends to 2 plus. You see 2 plus means slightly greater than 2 means up to equal to 2 only this one. Greater than 2 means this function you have to take. 2x minus 3. Now you tell me 4 minus 3 that is equal to 1. 2 into 2, if you apply limit automatically 2 into 2, 4 minus 3, 1. 7 is not equal to 1. Not continuous, discontinuous. Discontinuity at 2 only. That's all. I already told you. Okay? Write down. The function is... No, directly you don't write. You first you write this one. Limit extends to... Because this is good procedure. Limit extends to 2. F of x is not equal to limit extends to 2 plus f of x. Okay? 7 and 1. Therefore, now you write down. Therefore, the function is discontinuous at x is equal to 2. Okay? The function is discontinuous at x is equal to 2. Find the all points of discontinuity. This is the point of discontinuity. Remaining all continuous only. Okay? Let us go for 7th question. Okay? Okay. See the 7th question. 7th question you see here. Minus 3. 3. Okay? In 2 area, point of discontinuity may occur. May occur. That means, see what I am writing. You simply observe first. See, less than or equal to minus 3 means minus infinity to up to minus 3. Why? Because equal to is there. This function is continuous. Okay? You need not check and again. Minus 3 if you check, limit extends to minus 3. Left hand limit you need not check. Again, right hand limit you have to check. Why? Because from minus 3 greater than minus 3, x is greater than minus 3, another function is there. That means again you see what I am writing. From minus 3 to 3. But both are open intervals. You see equal to is not there. That means this bracket will come. Here closed bracket has come. Why? Because see equal to is there. In between, this function is continuous. Minus 2x is continuous. You understand now? That means you need not check in between. Continuous only. That means here minus 3 you have to check 1 point. 3 you have to check another point. 3. In 2 points you have to check. See here also greater than 3 equal to or greater than 3. Okay? Equal to is there. This function will come. This bracket will come. Then up to plus infinity, that's all. Again function is continuous. That means see limit 3 if you find, then limit 3 plus you need not find. Why? Because both are same. Here limit 3 minus you have to find. Why? Because equal to find me equal to 3 means this function will come. This function. Okay. That is why you have to keep in your mind. That means where we have to check now point of discontinuity for sake at x is equal to minus 3, at x is equal to 3 you have to check. You see here x is equal to minus 3, x is equal to 3. These two areas you have to check. Okay, let us check. Sometimes maybe at both points continuous, sometimes maybe at one point continuous, one point discontinuous, sometimes maybe at both points discontinuous. That depends on the function. Let us see what will come under. Okay, first continuity at x is equal to minus 3. Write down. Continuity at x is equal to minus 3. Okay, I am writing this one. You see, at x is equal to minus 3 means what you have to write? Limit x tends to minus 3 f of x, that is equal to limit x tends to at limit x tends to minus 3, what function you can take? See, equal to is there. That is why you have to take modulus x plus 3. Okay. And what will be the answer? You see, I am writing here modulus minus 3 plus 3, that is equal to 3 plus 3, that is equal to 6. Is it correct? Definitely correct. Okay. Now you need not see left hand limit. Why? Because left hand limit also going to give same result. But you have to see right hand limit of minus 3. The function is going to change. Okay, write down. Right hand limit comma limit x tends to minus 3 plus. Right hand limit is minus 3 plus f of x. That is equal to limit x tends to minus 3 plus. Minus 3 plus means greater than minus 3. Greater than minus 3 means minus 2x. That is equal to minus 2 into minus 3. 6. See, both have same. That means at minus 3, this function is continuous. Okay? Write down. The function is continuous at x is equal to minus 3. Okay? This, okay. But at x is equal to 3 may be discontinuous or may be continuous. We have to see that also. If both area continuity is there, means this function is continuous and there is no point of discontinuity, right? We can write. Okay? Let us proceed further. Write down. Continuity at x is equal to 3. Write down. Continuity at x is equal to 3, comma, limit x tends to 3, f of x is equal to limit x tends to 3. Now wait and write. You see, equal to 3, where is there? Equal to 3, here only is there. First you have to take this one, not here. Okay, here less than 3, equal to 3. Write down 6x plus 2. That is equal to, if you apply limit, 6 into 3 plus 2, that is equal to 20. Is it correct? 18 plus 2. Correct only. Okay. Okay. Now you tell me, shall we take left hand limit or right hand limit? You see here, right hand limit if you take also same thing is going to come. Why? Because 3 equal to and greater than 6x plus 2. Okay. But left hand limit less than 3, if you take, automatically function is changing. Then here maybe discontinuity maybe there, like that you have to think. That means left hand limit only you have to take. Write down. Left hand limit comma limit x tends to 3 minus, left hand limit means f of x, that is equal to limit x tends to 3 minus f of x means what here? 3 minus, if you see, minus 2x. That is equal to minus 2 into x is 3 here. 3 minus means not minus 3. This is 3 minus. Okay? 3 minus 6. Over. 20 has come at x is equal to 3. At x is equal to 3 minus 6 has come. Both are different. That means the function is discontinuous at x is equal to 3. That's all. Okay? X is equal to minus 3, it was continuous. But x is equal to 3, it is discontinuous. Write down the same. The function is, first of all you write this, limit extends to 3 f of x is not equal to limit extends to 3 minus f of x. Okay, both are different. Now write down, therefore the function is discontinuous at x is equal to 3. Okay, this is the answer for this question. Okay, take down this. We will go for 8th question. Okay, see the 8th question. This is a typical question. Carefully how to adapt your brain. F of x is equal to modulus x by x if x is not equal to 0. F of x is equal to 0 if x is equal to 0. Okay. Now you tell me where point of discontinuity we will see? At 0 only. Why? Because see, in 0 only functions are changing. Not equal to 0 means, see, minus infinity to up to 0. This function. From 0 to plus infinity, this function only. Why? Because in both this function only. At equal to 0 only 0. Okay? At equal to 0. That means 0 minus also this function, 0 plus also this function. That means you have to see continuity at x is equal to 0 only. If their continuity is there means continuous or else discontinuous. That's all. Okay? Why? Because see, x is not equal to 0 means you can write x is less than 0 once and x is greater than 0 once. Same. Okay? You need not write 2 times. That is why x is not equal to 0 they have written. There is one thing. Now you tell me x is not less than 0 means what you take for 0 left hand limit, right hand limit value here. You tell me now. See, every time we were taking, if it is 2, then 2 minus 2 plus, while substitution, here also substitute, you are substituting 2x plus 2 means 2 into 2 plus 2. Here also 2 into 2 plus 2 you are substituting. Here also 2 into 2 plus 2 you are substituting. Okay. 2 minus 2 plus means slightly less than, like you are telling, and you are substituting 2 only. But here you observe carefully, here these are multiplication and addition like. But here division is there, modulus x. Or not only modulus, even division is there. X by x are there. And you are substituting 0, 0 minus 0 plus. Then what value you are going to take? Here anyway you are taking 0, acceptable. But 0 minus also, do you take 0? When it is dividing? Wrong. Why? Because I am telling you, see, in real number line, this is 0, this is minus 1, this is plus 1. Okay? Plus 1. Okay. See, 0 is a special point. If you cross this side, it is going to become plus c. Whatever may be the value. Why? Because it may not be 1, but 0 point something means that is plus c. This side if you come, this is minus c. It may be very little, 0 point something, minus of 0 point something like. That means 0 minus means you have to take minus c, 0 plus means you have to take plus c. Why? Because that value we don't know, very small amount. Don't take 0 when you are dividing. When you are multiplying, you can take 0. That is acceptable. Why? Because why we are taking here, you see, if you take 0 minus, then minus c modulus by c. Sorry, minus c. Both area minus c only you are taking, but one area you are keeping this modulus means, see here, modulus out, it will come c minus c, that is equal to minus 1 will come. Okay. Right hand limit plus c modulus by plus c you take, both are plus only, 1 will come. You see, both are different. If you take both area 0, 0 means 0 by 0, 0 by 0. First of all, it is undefined. 0 by 0 you should not take. And you don't get any result. Both are going to become same. Why? Because this also we are going to take 0 same, this also we are going to take 0 same. There is no difference while making a division. That is why you have to take minus c plus c. When we are dividing, keep in your mind. When you are multiplying and adding, this side, both 0, 0 you can take. That is not a mistake. That is correct only. But because that is not going to make any difference. But here it is going to make difference. Okay? Minus 1 plus 1 both are different. Okay? That you keep in your mind. Let us proceed further. Now you tell me where is the point of discontinuity we have to check at 0 only. Let us write 0. First you write continuity at x is equal to 0. At x is equal to 0, limit x tends to 0, f of x is equal to. At x is equal to 0, what is there? Limit x tends to 0. At x is equal to 0, 0 is there. That means limit of a constant 0. Okay? Now you come for left hand limit. Left hand limit, right hand limit, both we have to do. Why? Because slightly less than 0 also this function, slightly greater than 0 also this function, only equal to 0 this function. Okay? Write down. Left hand limit, comma, limit x tends to 0 minus f of x, that is equal to limit x tends to 0 minus f of x is what here? Modulus x by x, that is equal to. Now you apply carefully. Here don't apply 0. You apply your brain. 0 minus means minus c by minus c, that is equal to c by minus c, that is equal to minus 1. Okay? C may be any constant nearer to 0. Okay. Like that you have to take it. Okay. Now again, see here itself we can say that 0 and minus 1 discontinuous, but even the right hand limit also you take. We will compare right hand and right hand limit and we will write the discontinuous at the. Okay. Okay, write down. Right hand limit, comma, limit x tends to 0 plus f of x. See, 0 minus 0 plus both are this only. At 0 only 0. Okay? Write down. Limit x tends to 0 plus modulus x by x. Now you tell me here what you are going to do. 0 plus c. Plus c you have to do. Write down. Plus c. Plus c modulus by plus c, that is equal to 1. Why? Because plus c modulus, after modulus also plus c only, that is why divided by 1. But here minus c modulus c will come near minus c, down in denominator, minus 1. Okay? Now you tell me minus 1 and plus 1 are equal? No, not equal. Then what you have to write? You have to write like this, you see. Limit x tends to 0 minus f of x is not equal to limit x tends to 0 plus f of x. Therefore, the function is discontinuous at x is equal to 0. Point of discontinuity is 0. That's all. Okay. Now you understand now. This is carefully how to do such questions comes means. If you substitute 0, 0, then there is no use. 0 by 0 definition is not there. That is also important. But limit 0 by 0 means some thing we have done earlier. But here we cannot do anything. Okay, limit x tends to 0, sin x by x means 1 by sandwich theorem and all. Like that, or factorization and all are there. But here you cannot do any factorization also. That is why you have to apply your brain. Okay, let us go for 9th question. See the 9th question. F of x is x by modulus x if x is less than 0, minus 1 if x is greater than or equal to 0. Okay. Here also you tell me from minus infinity to 0 or 0 minus, this is the same function, continuous function. Equal to 0 and above up to infinity, that means closed bracket 0 and infinity, minus 1 is the function. scalar function or like constant function. Okay. Now you tell me, where is the point of discontinuity if it is there occur? At 0 only. Why? Because at 0 only functions are changing. You see, equal to 0 is this function, greater than 0 also same function, but less than 0 means again this function is coming. That means function is changing at 0. Where you have to find the continuity? We have to find the continuity at x is equal to 0. Then you can find whether continuous or not. Okay. Let us proceed further. Here also you see x divided by modulus x has come, means x than less than 0 minus means what you have to take? Minus c, you have to take x. Okay. That you keep in our mind. Let us proceed. Continuity at x is equal to 0. Comma, limit x tends to 0, f of x is equal to limit x tends to 0. You see now, when you are finding limit at x tends to 0, then you have to see equal to 0. Equal to 0 is what? Minus 1. Then you write minus 1. That is equal to minus 1. Is it okay? Definitely okay. Why? Because see, when x is equal to 0, then minus 1 only you have to take. That's all. Scalar function like constant function. Limit doesn't matter for scalar function. Directly that scalar value is going to come. Okay. Now you tell me, is there any requirement to take right hand limit? Why? Because greater than 0 also same thing is going to come. That means we don't take right hand limit. Left hand limit we take. Why? Because less than 0 function is changing. Okay. Let us proceed. Left hand limit. Left hand limit. Comma, limit x tends to 0 minus f of x, that is equal to limit x tends to 0 minus, see 0 minus means what is this function? This function x by modulus x. Now you tell me, do you substitute or apply 0 0? No. Why? Because 0 minus means while division, see if multiplication is there, then 0 0 you can put. But while division, automatically what you are going to do? You are going to do minus c. Minus c by minus c modulus, that is equal to minus 1. Why? Because see, this minus c modulus will come plus c, but here minus c is there. Minus c by plus c minus 1. Okay. Now you tell me both are minus 1. Whether is it continuous or not? Continuous only. You see, without doing this question, if somebody sees means there may be discontinuity at 0. Maybe at 0. But after doing, we came to know that this is continuous. Then you write continuous. Okay. Write down. How to write? No, first you write this one. Why? Because see, limit extends to 0, f of x is equal to limit extends to 0 minus f of x. Therefore, the function is continuous. There is no point of discontinuity. See, at x is equal to 0, continuous means remaining area, it may be discontinued, like somebody may ask, but there is no chance of discontinuity. If greater than 0, completely minus 1. Less than 0, completely x by delta, modulus x. That is why there is no question of discontinuity. Okay, if at all discontinuity is there, it should be there at 0, but at 0, this is continuous. That's all. Okay, like that you write and close. Let us go for 10th question. Okay. See here this question. F of x is equal to x plus 1 if x is greater than or equal to 1. X square plus 1 if x is less than 1. Now also you tell me here minus infinity to 1. That means 1 minus. Here 1 equal to not there. That is why you can say 1 minus. Minus infinity to 1 minus. This function is continuous. 1 to plus infinity x plus 1. This function is continuous. If at all there is a discontinuity, it will be the discontinuity will be at 1. That means you have to see the continuity at x is equal to 1 only. Okay? Write down continuity at x is equal to 1. Continuity at x is equal to 1, comma, limit x tends to 1, f of x is equal to limit x tends to 1. See, now, see, this is not 1 minus or 1 plus, left hand or right hand. That means equal to 1, where is there, that function you have to take. Here equal to 1 is there, you see. That means you have to take x plus 1. Okay? Apply limit 1 plus 1, that is equal to 2. Is it correct? Definitely correct. Why? Because in x area I applied 1. Okay. Now see, now you see, equal to and greater than this one means you need not find a right hand limit. You have to find only left hand limit. Less than 1, some other function is there. Okay? Left hand limit. Write down left hand limit. Left hand limit, comma, limit x tends to 1 minus f of x is equal to, okay, limit x tends to 1 minus f of x is equal to, okay. See, first of all you write down limit x tends to 1 minus, then you tell me what is f of x less than 1, 1 minus this one, x square plus 1. Now you apply limit. Here you see, easily you can put at one area 1, even 0 minus also 0 only you are going to give. Why? Because this is addition and multiplication like. In addition and multiplication area you can apply 0 also like that only. But when it comes to 0, see, logically if you think x by x you are making means at 0, okay, some other value will be there, they don't define this. But slightly less than 0, 0 minus means say that may be 0.00000 minus 1 may be there. Again you are dividing same thing, minus 0.000001. Naturally this value should come 1. If you keep 0 by 0, that may be undefined, or it may come 0 or something, some other will come, but 1 will not come. Na? Here 0 by 0 never become 1. We don't know what is the value of 0. But here it should come 1. If at all modulus is there means 1 will become plus and 1 will become minus 1. Minus and plus 1. That means minus 1 will come. That is why you should be very careful while dividing. 0 minus 0 plus in division is there, then carefully you have to take it. This value we don't know, that is why you take minus c. 0 plus means plus c. Like that you take it. But here that question, that condition is not there. Directly you can apply. 1 square plus 1, that is equal to 2. Okay. See, by seeing we confuse that it may become discontinuous. But you see continuity only. Why? Because 2 both are same. Okay. Now you write. What you are going to write? Like this you are going to write. Limit x tends to 1, f of x is equal to only. Because both are 2. Limit x tends to 1 minus f of x. Therefore, the function is continuous. Continuous at x is equal to 1. At x is equal to 1. Point of discontinuity they asked in heading. What we have to write? There is no point of discontinuity. There is no point of discontinuity. Okay. See, you might have think in one first question, second question, third question and all elaborately we have done. Because we have done elaborate answers there, that is why we could able to do small answers here. Okay, wantedly I have done there. Why? Because this left hand limit, right hand limit concepts you should get in your brain very accurately. Then these questions are going to become very easy. Okay. Now we finished question number 10. We will stop this class here. Remaining questions and all we will try to solve in next class. Why? Because see, 34 questions are there. I think 2-3 more classes may take. Thank you very much.